Today, I want to tell you a story about the origin of the suffering of majority of the students in the whole world. Yes, I will tell you the history of the fundamental theorem of calculus, FTC for short. This is going to get boring, isn't it? Anyways, our story starts a long way back. It started during the time of the ancient Greeks. The first step was contributed by Zeno of Elea, who gave problems based on the infinite. The second step was a team effort by Leucippus, Democritus, Atiphon, and Eudoxus. The four made input on the Greek method of exhaustion, which is simply the method of finding the area of a shape by inscribing a polygon inside. You could say it's the early form of integral calculus. The last step of the ancient Greeks was made by none other than the Eureka man, Archimedes. Archimedes was said to aid the most out of all the ancient Greeks in creating, quote unquote, calculus. He did a lot of stuff. Wow, that's really specific. But what stands out the most was the integration of various shapes, such as circle, cone, and sphere. Woo! And that ends the ancient Greeks. FTC started gaining real foundation starting from the late Middle Ages to the Renaissance. There are several people who contributed to this foundation. Some of them are Nicole Orsim, Giordano Nemoriarius, Francois Viet, René Descartes, and Bonaventura Cavalieri. Okay, this is getting long. Skip ahead. FTC started to be official when a man named Isaac Barrow published the first statement of FTC in 1674. Isaac Barrow was what? Isaac Newton's teacher. Oh, standing on the shoulder of giants never made more sense, and was credited for his contribution in the discovery of the FTC. He gave a proof of the fundamental theorem to the relation of the inverse tangent to the definite integral. Aside from him, there are three more men who gave proof of the FTC independently of each other. These men were James Gregory, Isaac Newton, and Gottfried Leibniz. In the 19th century, Augustin Louis Cauchy gave the first rigorous definition of limit, convergence, continuity, and derivative. He then used this definition to give the first successful rigorous foundation for calculus. This definition would in turn give way for Riemann's integrability, which allowed for significant generalizations to be made. Fast forward, and then we have the modern world of FTC. Welcome to hell, students. Let's move on, even though I can't. I am now going to show you the mathematical proof of the first part of FTC. Okay, first let's assume stuff. Yes, in math we can make assumptions without getting hurt. Anyways, let's say we have a function, ft, which is continuous from a to b. Let's get some area under the graph. Let's call it the integral from a to x of ft dt. Now this area can also be defined as a function of x. Let's call it ax. So ax is equal to the integral from a to x of ft dt. The derivative of ax can be defined as the limit as delta x approaches 0 of a quantity x plus delta x minus ax over delta x. This came from the definition of derivatives. Remember it sometime. It might be helpful to you. Continuing on, ax is equal to this limit, so we can substitute it to ax leading to this. Let's graph this. Let's say this is x plus delta x. This definite integral is just equal to this area, and the other definite integral is equal to this area. So their difference is this area. We can calculate this area by multiplying base times height. So the base is delta x, and the height is some mean height. This was done in accordance to the mean value theorem. Oh my gosh, I said so many this. Let's square this part to the product of delta x and the mean height. This part is just equal to 1, so we only need to solve for this. We can see from this graph that as delta x approaches 0, the mean height approaches the height at x. This height is f of x. This means that a of x is equal to f of x, and the derivative of the integral from a to x of ft dt is equal to f of x. This is the first part of the fundamental theorem of calculus. Now, FTC2 is this. Side note, I said this 26 times, including this one. Wait, that's 27 already. Ugh. On a more positive note, let's try both on some examples. What? Thank you for watching, everyone. Goodbye!